study guide for Chapter 3 Geometry Test. Remember that I, as a teacher, go over the study guide. The student will do a homework sheet that looks like the study guide, and then there will be a test that looks like the study guide and the homework sheet. So no surprises. We want them to know what to study, and we want them to study it and be successful in their learning. Okay? All right. Tell whether the following is parallel, skew, or neither. Tell whether the following are parallel, skew, or neither. And so number one is AB and HG. So AB is this side, HG is this side. Parallel lines are coplanar lines that never intersect. Remember, we're thinking about the lines, not necessarily just the segments, you see. But you see the diagonal plane that those are part of? Those are two lines that are coplanar and never intersect, so they are parallel. Whoops, they are parallel. Plane ABCD, that would be the top. And plane EFGH. That would be the bottom. If this is a rectangular prism, which it's supposed to be, then the top and the bottom would be parallel. Two lines, I'm sorry, two planes that never intersect, we call parallel. AE. AE as a segment, we could consider the line that contains that segment. And plane HE, FG, it's obvious that those are neither parallel nor skew because they intersect at point E. So we're going to say that they are neither parallel nor skew. BF and DC. Segment BF is here. Segment DC is here. They are non-coplanar and never intersect. Two lines that are non-coplanar and never intersect, we call skew. Any questions on numbers 1 through 4? Number 5 through 8, special pairs of angles. Now what we're talking about here are alternate interior angles, corresponding angles, and same side interior angles. The formal definitions: alternate interior angles are two non-adjacent interior angles on opposite sides of the transversal. Corresponding angles are two angles in corresponding positions relative to the two lines. Same side interior angles are two angles in same side interior angles are two interior angles on the same side of the transversal. Non-formal definitions, visual memory, is that alternate interior angles make the letter Z. Same side interior angles make the letter C, and corresponding angles make the letter F. Don't forget also that we may visually be able to see angles called a linear pair and vertical angles, which are angles opposite each other when two lines intersect. So angle 5 and angle 10, number 5. We're going to find the vertex of angle 5. and then draw the rays that contain the sides and quit drawing when we get to another point. And then it says angle 10, and so we're going to draw its vertex, and we're going to go up to that point and then across, and we see that when we draw angle 5 and 10, they make the letter Z. Now those are equal if the lines are parallel. We don't necessarily know that the lines are parallel, so we simply identify angle 5 and angle 10, those two angles that made the letter Z. They are two non-adjacent interior angles on opposite sides of the transversal. We call them alternate interior angles. Angle 7 and angle 19. So we're going to find the vertex of angle 7, draw to another spot and stop, draw to another spot and stop. Angle 19, find its vertex. Angle 19 is kind of trying to hide from us here. It's this angle right here. Go to there, down to here, a little bit off here. When you put those together, they make the letter F. F's are corresponding. The formal definition is they're in corresponding positions relative to the two lines. So if we consider, I went too far. If we consider the two red lines cut by the red transversal, then angle 7 is in the bottom left position here, and angle 19 is in the bottom left position there. They're in corresponding positions relative to the two lines, or they make the letter F, corresponding angles. Okay. Angle 14 and 15. Angle 14's vertex is here. We'll draw its sides. Angle 15's vertex is here. We'll draw its sides. Those make the letter C. They're on the inside, on the same side, interior angles. Okay. Angle 21 and 24. Now that's kind of looking like a 21 right there, but that's not the 21. It's this one up here. So 21 with 24. Those are angles opposite each other. When two lines intersect, we call those vertical angles, and vertical angles are always equal. Vertical angles. So alternate interior angles, corresponding angles, same side interior angles, and vertical angles. Any questions on number 5 through 8? Numbers 5 through 8. Okay. All right, numbers 9 through 14. We're going to use everything that we have learned in geometry so far. First of all, there being a little arrow in the middle of that line and a little arrow in the middle of that line is telling us that these two lines are parallel. If you take those two parallel lines cut by a transversal, then that tells us that alternate interior angles are equal, corresponding angles are equal, and same side interior angles are supplementary. We also know that a linear pair is 180, and the sum of the angles of a triangle is 180. So if we know that this angle is 120, then the angle corresponding to it Angle 6 is also 120. We know that the angle that is a linear pair with it, which would be angle 4, adds up to 180 with it. So angle 4 would be 60 degrees. So we now know that angle 6 is 120 degrees and angle 4 is 60 degrees. We know that angle 4 and angle 5 make a Z, which are alternate interior, and they are equal if the lines are parallel. So angle 5 is 60 degrees, same as angle 4. So if this is 120, then this is 60, and this is 120, and angle 5 is 60, and we can't jump across that barrier because we don't have parallel lines, you see, with this is not parallel to this, so we can't jump across there. So we're going to have to do something totally different on this side over here. Over here we have a triangle. We know that the sum of the angles of a triangle is 180. So we could add the 50 and 70 and get 120. We know that an exterior angle, like angle 2, is equal to the sum of its two remote interior angles. So angle 2 is 120 degrees. There's two ways to get angle 1. The sum of all of the angles of a triangle is 180. If those two added up to 120, then angle 1 would be what was left, 60 degrees. Or it's a linear pair with angle 2, so it's 60 degrees. So we've gotten that angle 120 and angle 1 is 60. Now we do know that these lines are parallel. And if you cut those two lines by this transversal, then angle 2 and angle 3 are corresponding angles. They're both in the top right position, or they make the letter F. So if angle 2 is 120 degrees, then angle 3 will also be 120 degrees. So we're using the fact that if two lines are parallel, then alternate interior angles are equal, corresponding angles are equal, same side interior angles are supplementary, vertical angles are equal, the sum of the angles of a triangle is 180, and an exterior angle is equal to the sum of its two remote interior angles. There again, we have to know, recognize, understand, and be able to visualize every definition, postulate, and theorem in the book as we go. And as we get to a certain place in the book, we have to know those things cumulatively and be able to apply them. Okay? Any questions on numbers 9 through 14? 15 through 19. Using the information given, name two parallel lines and then tell what makes them parallel. It says angle 1 plus angle 6 plus angle 5 is equal to 180. So angle 1 is this. We're going to go all the way to where it talks about 6 and 5. Plus 6 plus 5. We're just going to kind of put 6 and 5 together, you see. Now, when you get angle 1, you got that. When you got 6 plus 5, we're just going to kind of say, well, that's just that, really that 1. If we want to say 6 plus 5 is the whole big thing, we could. So angle 1 up here plus 6 plus 5, that 1, that's a combination of 6 and 5, makes a C. Same sides make a C. And if they're supplementary, then the lines are parallel. And it says they added 180, which means they're supplementary, which means that the lines that form them, line AB and line DC, are parallel. Any questions on that? So we can conclude that AB is parallel to DC because same side interior angles are supplementary. Okay? All right. Number 3, angle 3 and angle 6. Angle 3, let's find where angle 6 is. We'll go all the way to its vertex. So there's the sides of angle 3. Angle 6's vertex is here. We'll go all the way to the vertex of angle 3. When you put them together, they make a Z. I know it's turned sideways and backwards. It looks like a backwards N, but if you turn your head sideways or stand on the wall and look forward, then you can see a Z. So they're alternate interior angles. If alternate interior angles are equal, then the lines that form them are parallel, and the lines that form them are AD, which you could have called AE or ED or DE or all those things, you know. So line AD is parallel to line BC, which you could have called CB or BF or FB or FC or CF, you know. Because alternate interior angles are equal. Any questions on that? Okay, angle 1 and angle 8. The vertex of 1 is here. We're going to go all the way to there. 1 is here. We're going to go all the way to 8. We start at 8. There's its vertex. We're going to connect and we get the letter F. It says they're equal. F's are corresponding. They're both in the bottom right position. Corresponding positions relative to the two lines, they make the letter F. Corresponding angles are equal. If corresponding angles are equal, then we can say that the lines are parallel. The lines that form them are line DC and line AB. So we can say that line AB is parallel to line DC because alternate interior angles are equal. And I don't think I wrote this up here, and I apologize. We can't say that they're parallel because they're same side interior angles. We have to say that they're parallel because same side interior angles are supplementary. Without that part on it, we've proved nothing. We can't say they're parallel because of alternate interior angles. that proves nothing. We say that they're parallel because alternate interior angles are equal. So make sure you attach that because it means nothing without it. Okay? And then it says EF is perpendicular to AD. Perpendicular lines are two lines that intersect to form equal adjacent 90-degree angles. So it's telling us that those are equal adjacent 90. It says EF is perpendicular to BC. Perpendicular lines are two lines that intersect to form equal adjacent 90-degree angles. Now this thing in the middle is called a transversal. Remember that there's four ways to prove that two lines are parallel. If alternate interior angles are equal, then the two lines are parallel. If corresponding angles are equal, then the two lines are parallel. If same side interior angles are supplementary, same sides make a C and they're supplementary, then the two lines are parallel. And the fourth way to prove it was if a transversal was perpendicular to both lines, then we could conclude that they're parallel. Here we have transversal EF perpendicular to both lines. Therefore, we can conclude that the two lines are parallel because the transversal is perpendicular to both. The lines are AD if we go from one end to the other, and BC, line AD parallel to line BC because the transversal is perpendicular to both. Any questions on numbers 15 through 18? And then on number 19, we said, okay, if you have a line and a point not on that line, exactly one perpendicular. In other words, you can only go through that and hit it at 90 degrees with one thing. If you tried to do it like that, it wouldn't hit at 90, wouldn't hit at 90, wouldn't hit at 90. Exactly one line perpendicular and one line parallel can be drawn. If you tried to make another one, it wouldn't be parallel, you see. It wouldn't be parallel, wouldn't be parallel. Through a point outside a line, exactly one perpendicular and one parallel can be drawn to the line. Given a line and a point not on that line, exactly one perpendicular and one parallel can be drawn to the line. Number 20, the triangle to the right could be named how many ways? Well, it has all angles less than 90, so you could call it acute. It has no equal sides. Now I'm making a mistake, aren't I? You know I was doing that. I was sitting there looking at that thinking, now, I don't draw things very accurate sometimes, so how am I supposed to know if that's equilateral isosceles? We're not right now. We can name a triangle, remember, from a point on one side, then the vertex, then a point on the other side. So we could start with A and call it triangle ABC, going counterclockwise or clockwise. We could start at A and go counterclockwise, wowie, and call it triangle ACB. So we could call it triangle ABC or triangle ACB, triangle BCA or triangle BAC, triangle CBA or triangle BCA. So we can name this triangle 6 different ways. That's what it's asking. Down here, we're going to get into acute, right, obtuse, scaling, equilateral, equal, angular, and all that. Okay? Name the sides of a triangle. Now let's go back to the definition. A triangle is a figure formed by 3 segments joining 3 non-collinear points. The 3 segments are called the sides. the three non-collinear points are called the vertices. So the sides are segment AB, which we could have called BA, segment BC or CB, and segment AC or CA. The vertices are those three non-collinear points, which are point A, point B, and point C. Any questions on the definition of and the parts of a triangle? Now we're going to classify a triangle according to the lengths of its sides and the measures of its angles. Remember that a triangle with no equal sides is called scalene. A triangle with at least two equal sides is called isosceles. A triangle with all three sides equal is called equiangular. If all of the angles are less than 90, we say that it is an acute triangle. If it has one angle that is equal to 90, we call it a right triangle. If we have one angle that is greater than 90, we call it an obtuse triangle. And we know that there can be at most one obtuse or one right angle in a triangle. So, number 23, have a triangle with two equal sides. That makes it isosceles. It has one right angle, so that makes it a right triangle. And so we have an isosceles right triangle. Remember that in a right triangle, the side across from the right angle, the larger side, is called the hypotenuse. And so the hypotenuse is side AB, the side across from the right angle. And the legs are the sides that make the right angle. And so the legs are side AC and side BC. So number 23, we have an isosceles right triangle. Number 24, according to the lengths of its sides, it has no equal sides. The word for that is scalene. It has one angle that's more than 90, that is an obtuse angle, and we say that it is an obtuse triangle. So number 24 is a scalene obtuse triangle. A scalene obtuse triangle. Now on number 25, we have two equal sides. We actually have more, but at least two equal sides is isosceles. The fact that all three sides are actually equal, not just two of them, makes it equilateral. All of the angles being less than 90 degrees makes it acute. And the fact that all of the angles are equal makes it equiangular. So it's an isosceles equilateral acute equiangular triangle. It looks like we've got a game of pool going there almost, right? Anyway, number 26 through 29. Angle A plus angle B plus angle 2. Angle A angle B, angle 2. Those are the angles of the triangle. We know that the sum of the angles of a triangle is 180 degrees. Angle 1 plus angle 2. Angle 1 and angle 2 are the acute angles of a right triangle. We learned from a corollary over the theorem about the sum of the angles of a triangle is 180 that the acute angles of a right triangle are complementary, meaning that the sum of their measures is 90 degrees. And we know that because a triangle is 180 degrees, and if the right triangle takes up 90, the other two have to take up what's left combined, which means that their sum is 90, which means that they're complementary. The acute angles of a right triangle are complementary. Angle 3 is equal to the sum of what two other angles? Well, angle 3 is an exterior angle of that triangle. We learned as another branch off of the sum of the angles of a triangle is 180, that an exterior angle is equal to the sum of its two remote interior angles. The two angles remote from angle 3, the two interior angles remote from angle 3 are those two. Angle 2 would be the angle adjacent to it. Notice angle 2 and 3 are a linear pair. The one adjacent to it is a linear pair with it. The other two we call the remote interior angles. So the exterior angle, angle 3, is equal to the sum of its remote interior angles, angle A and angle B. If that is true, then if angle 3 is 140 degrees and angle A is a right angle, which we know to be 90 degrees, and angle 1 plus 90 is equal to the exterior angle 140, then we could solve that by subtracting and conclude that angle 1 is equal to 50 degrees. Now, if angle 1 is 50 degrees and angle A is 90 degrees, then we could add those up and subtract from 180 because a triangle is 180. Or we could use angle 2 and 3 as a linear pair and say a linear pair is 180. And if angle 3 is 140, then angle 2 has to be what's left of 40 degrees. So two different ways that we could have found that angle 2 is 40. The sum of the angles of a triangle is 180, or a linear pair is 180. Any questions on 26 through 29? Okay. Numbers 30 to 33. We're talking about a regular convex hexagon. A hexagon has 6 sides. Be sure and memorize that triangle is 3, quadrilateral is 4, pentagon is 5, hexagon is 6, septagon 7, octagon is 8, nonagon is 9, decagon is 10, then you have an 11gon. A 12gon is also called a dodecagon, And then after that, you have a 13 gone, 14 gone, 15 gone. And if you left the bird cage open, Polly's gone too. But anyway, all right, had to say that sometime or another. The interior angle sum of a regular convex polygon is given by the formula the number of sides times minus 2, number of sides minus 2 times 180 degrees. So if we take the number of sides for a hexagon 6 and plug it in, we would have the number of sides 6 minus 2 times 180 degrees, which would give us 4 times 180 degrees, which would be 720 degrees for the interior angle sum of a regular convex hexagon. Now, if we wanted each interior angle, we would take that interior angle sum, 720, divided by the number of them, 6, and we would see that each interior angle of a regular convex hexagon is 120 degrees. The exterior angle sum of any polygon is 360 degrees, no matter how many sides it has, and so that's just 360. To find each exterior angle, you would take the exterior angle sum 360 divided by the number of side 6, and you would get each exterior angle at 60 degrees. So the formula for the interior angle sum of a regular convex polygon is n minus 2 times 180. Each interior angle of a regular convex polygon is n minus 2 times 180 over n. The exterior angle sum of a regular convex polygon, or just a convex polygon, is 360 degrees, and each exterior angle of a regular convex polygon is 60 degrees. Well, that brings us to isosceles triangle stuff, including the isosceles triangle theorem. Remember that an isosceles triangle is a triangle with two equal sides. The two equal sides are called the legs of the isosceles triangle. The two equal sides are called the legs. So the legs are RM and EM, segment RM and segment EM. The base is the third side, RE. The vertex angle is the angle that is included between, which would be angle RME. We have to use 3 letters because there's 3 angles at point M, or at the vertex M. We know that angle E is 50 degrees because if two sides of a triangle are equal, then the angles opposite those equal angles are equal. Angles opposite equal sides are equal. I hope I said that right. I say that backwards sometimes. Angles opposite equal sides are equal. We know that sides opposite equals angles are equal. And sometimes I say one when I'm thinking the other one. Angle MHE. MHE. Here we have an isosceles triangle. It was given to start with that this angle was equal to this one. It was marked, which means that this is the vertex angle bisector. The isosceles triangle theory says that the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. That means that angle MHE is 90 degrees because of the isosceles triangle theorem. And angle HME is 90 degrees because of the isosceles triangle theorem. And segment RE is equal to 12. We know that because of the isosceles triangle theorem, and the midpoint means those are equal. And so if that is 6 and that is 6, then the whole thing is 12. We know the whole thing is 12 because the little pieces are equal, and the little pieces are equal because it's a midpoint, and it's a midpoint because we had 2 of the 4 things in an isosceles triangle theorem situation marked. Therefore, we can conclude that the other 2 are true and justify it with the reason isosceles triangle theorem. What were the other 2? That it's a midpoint and that those are both 90. There's that those are both 90, and that came out of the concept of that being the midpoint. Any questions on the isosceles triangle theorem? Okay. Angle 1 and angle 2. Now, given that angle 1 equal angle 2, prove that ray HP bisects angle FHG. Now, remember, when we do only reasons, we're going to create a note section. We're going to take what we're given, mark it in the diagram, write statements and reasons derived from the markings in the note section. When we go to give reasons, we're going to look first in the given, second in the diagram, which includes the note section, and third in the statements above. So, we're going to go to statement 1. It says angle 1 is equal to angle 2. We look first in the given. It's there, and so we put given. And so we go to the second statement. Now, I didn't do what I said I was going to do, did I? I should have taken that given, angle 1 is equal to angle 2. And I should have marked in the diagram what I marked in the what it said. Write down in my note section what I marked, and since what I marked is what I was given, I would have put given. Now there's no other conclusion we can reach from that given, so that's all that would be in the note section. Okay. So now we go to the second statement. Angle 2 is equal to angle 5. We look first in the given, and it's not there, so it's not given. So we look second in the diagram. Angle 2 and angle 5. In the diagram, we recognize angle 2 and 5 as being angles opposite each other when 2 lines intersect. We know those to be vertical angles, and vertical angles are always equal. And so we go to the next given statement, angle 5 is equal to angle 8. We look first in the given, and it's not there. So we go to the diagram at angle 5 and angle 8. Angle 8 is here. Angle 5 is here. The little bitty arrows in the middle of the lines are saying that those lines are parallel. If those lines are parallel, angle 5 and 8, if you notice, make the letter F. Those are corresponding. The arrows say parallel. We can say that those are equal because corresponding angles are equal. If 2 lines are parallel, then corresponding angles are equal. And then we go to the next statement. and it says that angle 1 is equal to angle 8. Now, let me get some of that stuff out of the way so I can show you kind of what we did. We took the given and marked it. Angle 1 is equal to angle 2. And then we got to the statement angle 2 is equal to 5, and then we had marked that angle 2 was equal to angle 5 because they were vertical angles. And then we got to another statement, and it said that angle 5 was equal to angle 8 because they were corresponding. So now when we look at that, 1's equal to 2, and 2's equal to 5, and 5's equal to 8. They're all kind of equal to each other. What does that make you think of? A whole bunch of things all equal to the same thing. This equal this, and this equal this, and this equal this, so blah equal blah. That's a transitive property situation. Now, if we line it up properly with transitive, then what we have to start with here should have been at the beginning of a long string of equal stuff. And what we end up with here should have been the end of that long string of equal stuff. And in the middle stuff should kind of just flow, right? And I really wish that that would have hit, right? That would have looked better. So we've got if 1 equal 2 and 2 equal 5 and 5 equal 8, then 1 equal 8, transitive property of equality. Learn that one in algebra and in geometry. Okay? And then it says write HP bisects angle FHG in the last statement will always be justified in the statements above it. It says angle bisector. Now, the most common way that you're going to get a word will be definition of. And that's what we're going to have here because it says angle 1 equal angle 8. We need to validate that in the picture. Let's just kind of get this out of the way so we can go back to the picture and try to validate that. Angle 1 and angle 8. There's angle 1. Here's angle 8. It gives us in statement 4 that angle 1 is equal to angle 8 because of all that transitive stuff. We're trying to conclude here that this ray bisects that whole big angle. Well, that's obviously that it does because the definition angle of an angle bisector said it's a ray that divides an angle into two equal angles. We have the what we get out of it, the two equal angles, right here. The word angle bisector, there's the word, there's what we get out of it, and so we say definition of an angle bisector. Any questions on giving the reasons for the proof? Okay. Draw and label the example accurately. And I'm not going to pull in drawing devices, but I will try to show you how you would get this done. You want an isosceles right triangle ABC with vertex angle at A and the legs are 1.4 centimeters. Okay. What you could do is try to create your vertex angle A. And what I would do is get a compass, get the little pointy part, and then the pencil. And I would open it to 1.4 centimeters. Now, you know a centimeter is about the width of your thumbnail, so we're talking about opening it up to that. Okay. And I would put the pointy part right here, and I would put the pencil part right there, and I'd make an arc. which I didn't draw a very good arc. And then I would pick any 2 points on that arc and connect, and I would have an isosceles triangle whose legs are 1.4 with a vertex angle of A and the other two sides at B and C. See how we would do that? Okay. Regular pentagon with one of the sides at a centimeter. Now, you got to know what the angles are. If it's a regular convex pentagon, to find each angle, you would take n minus 2 times 180 degrees divided by the number of sides in, which is 5 minus 2 times 180 divided by 5, which is 3 times 180, which is 3 times 180 divided by 5, which is 540 degrees divided by 5, which is 108 degrees. For each angle of a pentagon. So what you're going to do is measure your little 1 centimeter. So you'd get you a spot to start with, and you'd lay your little ruler down there. And you would go 1 centimeter, which is a little bitty like that. And you're going to get your little 1 centimeter line. And then you're going to lay your protractor on there. That's the little thing that makes circles, you know. And it's got the little hole, and you'd put it on the one corner down here. And then you would figure out 108 degrees. And you'd make a mark. So you would have to kind of start here and go 108 degrees and kind of draw that way. And you'd have to lay your protractor down and go 108 that way. And then you would measure 1 centimeter up and 1 centimeter up. And I'm not doing my 108 very good, but you understand. And then you'd get your protractor and you'd figure out 108 degrees again and 108 degrees again. And then you would measure 1 centimeter again and 1 centimeter again. And they should hit up here. I did a really nice job of illustrating, but you understand that. You would draw one side, measure 180 degrees each way, sing them, stick you another centimeter on each one and go from there, okay? All right. And that was the end of the Chapter 3 review. Do well on the homework, study hard for the test. Good luck.